In this video, we work through IBHR Mathematics Paper 3 times on 3 questions. If you want to improve your proof skills, we will focus on algebraic reasoning, structure, and simplifying expressions. Let's begin with the first question. Question 1. This question asks you to explore self-composite linear functions of the form f of x equals mx plus c for varying values of m. A function composite with itself is called a self-composite function. For a function f, the function composition with itself is given by, there's an expression in here, f of x. Let f to the power of n denote the n composition of f with itself, where, so this is the expression of the n times f composition of f. Hence, for example, the second composition function f is given and the third composition of f is given. Consider linear function f of x equals mx plus c. Show that the second composition function is m square x plus c times 1 plus m. Let's show it first. We know that f of x equal mx plus c, and we're gonna find the second composition, which will give us f of x. In this case, I will replace x with mx plus c, right? And m times mx plus c will give us m square x plus mc plus c, yeah. So from here you can write m square x plus c in parentheses m plus 1. The second question is as for the third composition of f, right? And the third composition of f is, we can write in this case, it's given like f o f o f o x, but I just found here, so I can also substitute this expression and m square x plus c times m plus 1, right, in this expression. Replace x with again m square x plus c times m plus 1 plus c. And when we simplify it, our goal is to find this expression. So m to the power of 3 times 6 plus, in parentheses, I would like to write directly m square plus m plus 1. Yeah. If you ask for where does it come from, I can write like first m c times m plus 1, right? Plus c. And then m to the power of x plus, now you can write it c times m squared plus m plus 1, right? Yeah, this is the second question. Yeah, the next question is write down an expression, the fourth composition of f. Okay, the fourth composition of f, it's gonna be, we found it, the third composition in the previous question. So for example, I will write directly inside of the third composition the function itself. In this case, this will give us the fourth composition, meaning to the power of, I found this expression, and I will replace x with the function itself again, mx plus c, right? Yeah. And when we combine the like terms and simplify this expression, m to the power of 4 times x plus m to the power of c plus, here is will not change, and c times, we can write 1 plus m squared plus m to the power of 3, right? Yeah, as you see from here, the power of m is increasing by 1, and this term is also increasing by 1. Suggest a similar expression for the end composition. Okay. Yeah, as you see from the previous questions, there is a sequence here is going to the m power, right? And in parentheses, 1 plus m squared plus the terms going to till m to the power of n minus 1, because as you see from here, when the power is 4, it's, the composition, the fourth composition. The last term in here is the power of this term is 3, right? Which is 1 less than 4. And the last question of B is, by using your expression from part B2 or otherwise, find an expression in terms of n for n composition of f when m equal 1. We will just replace m with n, right? In here, and composition of f at the point 1, or not 1, but m is 1. I will not change the x, I will just change m, right? Yeah. So here is gonna be x plus c times 1, 1, 1. Yeah, there is n times 1 in here, right? Then there is n terms because I know here will give us x plus n times c. Yeah. Next question is, for m does not equal 1, use mathematical induction to prove that the end composition of the function, right? Okay, so let's remember the mathematical induction to prove it. We can say that for n equal 1, the statement is, let's take it by the way. Yeah, let's write it for n equal 1, meaning f of x equal mx plus c times 1 minus m divided by 1 minus m equal mx plus c, right? Which is correct. This statement is true. Okay, yeah. And assume for n equal k, the statement is true, meaning f the k composition of f will give us this statement, and our goal is to show that for n equal k plus 1 the statement is true. From here you can write the k plus 1 composition of f equal f of the k composition of the function. So we can use now m times this expression that we found or assume before, right? M plus c will give us m to the power of k plus 1x plus c times m minus m to the power of k plus 1 because I'm distributing into this parenthesis plus c. From here you can say m to the power of k plus 1x plus c in parenthesis m minus m to the power of k plus 1 plus c minus cm. Sorry, 1. If we take in parenthesis, it will be 1 here. Yeah, from here, we're gonna say c in parenthesis m minus m to the power of k plus 1 plus 1 plus m minus me m will be m to the power of k plus 1x plus c times, let's say in parenthesis 1 minus m to the power of k plus 1 divided by 1 minus m, right? So we show that, so we can say, hence, if it is true, or if the statement is true for n equal k, it is true. It is also true for n equal k plus 1. Therefore, it is true for all n. Yeah, that's it. The next question is, consider the end composition. It's given in here, the expression, and m is between -1 and 1. As n approaches infinity, the family of graphs of the end composition of f approach the graph of a straight line L. Determine the equation of L, giving your answer in terms of C and M. Okay, we're gonna look for n approach infinity, and m to the power of n, x, plus c times 1 minus m to the power of n divided by 1 minus m approach. I know that here is gonna be 0 because m is between -1 and 1. So 0 plus c times 1 minus 0 divided by 1 minus 0, we can say. Or here is gonna be, wait, here is gonna be m. Yeah, sorry. So, which means c times 1 over 1 minus m, we can write the line y equals c times 1 over 1 minus m. The next question is consider again and composition of f where m equals minus 1. Show that this function is odd function. Okay, let's write the function again itself. Yeah, we're gonna replace m with minus 1 first. So it will be minus 1 to the power of n here, right? Divided by in here 1 minus 1. I know that n is odd. If n is odd, it is gonna be minus 1, or you can just write minus x plus c times in parentheses. Let's check it here. Here will be minus 1. 2 divided by 2 will give us minus x plus c. Yeah, we show it. At the next question, find an expression for the same function when n is even. So if n is even, it will be x plus c times 1 minus 1 divided by 1 minus 1, right? So it is x plus 0 or x, only x, yeah. Maybe you can just mention that when n is odd, minus 1 to the power of n equal minus 1. You can write in parentheses n is odd. And in here you can write minus 1 to the power of n will be 1 when n is even. Okay, yeah. Question 2. This question asks you to consider open-topped boxes formed by cutting square corners from an A times B sheet of cardboard and folding the size. In particular, you are asked to investigate conditions for which the maximum volume of a box is an integer. A rectangular sheet of cardboard measures A centimeter by B centimeter, where A less than B. A square of side length X centimeter is cut from each corner, and the resulting sheet of cardboard is then folded to form an open-topped box with a rectangular base. This is shown in the following diagrams. The volume V centimeter cube of a box is given by V equals, there's an expression here, x between 0 and a over 2. Write down the value of V when x equals 0, x equal a divided by 2. Okay, first we can just will replace x with 0 first. When we replace x with 0, you will see that volume will be 0, right? Because it's gonna be 0 times, yeah, this will give us 0. And again, in the same manner, if you replace x with a over 2, let's replace it. A over 2 times a minus, it's gonna be a times b minus 2 times, it's gonna be again a, will give us 0 too. Show that v equals 4x cubed minus 2 times a plus b times x squared plus abx. Okay, I know that v is given us x times this expression, right? I will just simplify this expression. First, I would like to multiply the last two terms. It will be easier. AB minus 2ax minus 2bx plus 4x squared, right? Yeah. And when you distribute x into this expression, you will see that abx, or before you can just, yeah, abx minus 2ax squared minus 2bx squared plus 4x cubed, right? And again, combine the like terms, 4x cubed minus x squared, or I know that 2 and x squared is common for these two terms. And you can write like a plus b in parentheses plus abx, okay? Show that the only solutions of dv over dx, which is derivative of the volume, okay, when it's equals 0, we're gonna find the derivative of the volume. Dv over dx equals, just be careful in here, we found already the function v, and the derivative of the first term is 12 x squared minus 4x times a plus b plus ab, right? Yeah. Equate this to the zero and check for the roots of this equation. We can apply the discriminant formula, will give us x. X equal, I know that the formula is minus b plus minus square root of discriminant, which is b square minus 4ac divided by 2a. B is, do not confuse here because B is the coefficient of x in here. So it is 4 times A plus B plus and minus in the square root of, in this case, the square of B will be 16 times A plus B square, right? Yeah, from here you can write minus 4 times A is the coefficient of this is the leading coefficient A, and c is the constant without x, this one. We will divide it by 2 times 12, okay? Simplify this expression, 4 times a plus b plus and minus square root of, by the way, you can take I know that here is a factor 16 and there is also a 16 factor here. We can take this number out of the square root. So it will be 4 times square root of a plus b square minus 3 times ab, right? Because when we divide 48 to the 16, it will give us 3. Here is 24. And again, simplify. You can cancel for numerator and denominator. A plus b, here is gonna be 6. A plus b minus or plus square root of a square plus 2ab plus b square minus 3ab divided by 6. And the last step is in square root a square minus ab, right? When you subtract this ab plus b square. Yeah, that's it. We show it, I guess. Yes. The next question is in parse DNA, the following three results are given. The first x lies outside the interval between x0 and a over 2, and the other x lies inside the interval. Square root of a square minus ab plus b square greater than 0. Let x sub m equals a plus b minus square root of a square minus ab plus b square divided by 6. Use the second derivative of v in terms of x to show that there is a local maximum of v at x equals x sub m. So how are we going to use the second derivative of the function? We found the first derivative, right? Let's check it. The first derivative here. Okay. Oh, this one, the first one. In this case, we're going to find the second derivative by find the derivative of this function. It will be the first derivative of the first term is 24x minus 4 times a plus b, right? So how we gonna use this formula to show that there is a local maximum over there? Because xm is this one. Let's take it also. Okay, we will just substitute this expression x sub m into this second derivative function. If the second derivative is less than 0, meaning this x sub m will be local maximum because the graph will be like this, and when this is concave down, it is the second derivative is less than 0, okay, for a local maximum in here. I will just substitute this value into this expression and to check whether it is less than 0 or not. And or you can directly write 24 times x that we found in or is given at the equation sub m minus 4 times a plus b. Yeah. Simplify this expression. You can cancel 6 in here. It's going to be 4. But 4 times a plus b also will be cancelled. In this case, there will be just minus 4 times square root of a square minus ab plus b square. And it's given that at the equation, this expression square root of will be greater than 0. So in this case, this expression minus 4 times square root of will be less than 0. Hence, x sub m, or our goal is, yeah, hence there is a local maximum at the point x equals x sub m. Okay, yeah. Use your answer to parse A and D to explain why x sub m will give the maximum volume v sub m of the box. At the first question, we show that when x equals 0 or when x equals a over 2, the volume is 0, right? Meaning this is the boundaries of this length x. So you can say that a maximum point will occur either at endpoints, which is here, or a local maximum point. Okay, you can say the maximum value will occur either at endpoints or at local maximum point. Yeah, the next question in parts F to H, consider a method for generating sets of positive integers values for x sub m and hence v sub m. Consider the case where a equals to st minus s square, b equals t square minus s square. Given that a less than b, show that t greater than 2s. Okay. A, b is given in here. Yeah. So I know that a less than b, meaning 2st minus s square less than t square minus s square. So you can cancel s square in here, and I know that t is a positive integer. You can also cancel t if you know that this is positive integer. So you can write 2s less than t. And the next question is given that square root of a square minus ab plus b square equals s square minus st plus t square. You are not required to show this result. By substituting for each of ab and this expression in terms of s and t, show that x sub m equals s times t minus s divided by 2. Okay. X sub m, this one. You know this, and yeah, the square root of also, I will use that one. I will use this one and expression in square root. And we already know the expressions a and b in terms of t and c, right? Okay. Let's start by substituting first a and b. I know that 2st minus s square plus t square minus s square minus square root of, we don't need to write all of the expression in square root because it's given like this. If you just change the sign, a square plus st minus t square will be divided by 6, and simplify the numerator. First in parentheses maybe 2st minus 2s square plus t square minus s square minus t square minus st. Yeah, there is minus 3s square, right? And t square cancel plus st from here divided by 6. Yeah, equal, you can cancel. We're gonna show like what? Yeah, there is, let me check it. Oh, here is gonna be positive sign plus. In this case, that is here plus, and it will be 3st. We can cancel 3 minus s square plus st divided by 2. If we write s as a common factor, and we need to write it or not. Yeah, s in parentheses t minus s divided by 2. Yeah. The next question is given that AB is a positive integer, use V sub m to explain why S being even implies that V sub m is an integer. Yeah, so this is Vm, right? And I know that X sub m equal s times t minus s divided by 2. If s is even, then x sub m is integer, right? Because I know that here is even, and it can be cancelled with 2. In this case, x sub m will be integer. Therefore, the factors, or you can just write, therefore v sub m is integer. Okay. The next question is, state another condition on S and the corresponding condition on T that implies that both x sub m and v sub m are integers. Yeah, the first case is S is even, but if we choose that S is odd and T is odd, if S and T are odd integers, then x sub m is integer, therefore v sub m is integer. Yeah. So the last question, it asks for hints or otherwise find an integer value of x sub m and the corresponding integer value of v sub m. If you see that the t greater than to s, you can just, for example, choose s equal to, and in this case, t can be, because I know that 2s will be 4, you can choose t 5. I will write in here s equal to, t equal 5, right? Yeah. So in this case, exam will be s is 2 times 5 minus 2 divided by 2. It is 3. And v sub m will be, let's write 3 times a. What is a? Let's find this 2a. Okay, a is, yeah, a will be 2 times 2 times 5 minus 2 square, and b will be 5 square minus 2 square, right? A is 20 minus 4 is 16. 25 minus 4, it is 21. Okay, I will write v sub m in here. It is 3 times it was, and a minus a is 16 minus 2 times 3 times b minus 21 minus 2 times x sub m, 2 times 3. And 3 times in parentheses in here, 10 times here, 15 will give us 450. Yeah, that's it. Yeah, we saw all of the questions of paper 3 times on 3. If you found this helpful, please like and share the video and check out my YouTube channel for all exam paper solutions. Thank you very much for watching. Take care. Bye bye.